Hello everybody, we're getting ready to do lesson 21 for SAT Math Level 2 Prep today. And lesson 21 will have 18 points on your notebook, 14 points into your classwork sheet, and 21 statistics, mean, median, mode, range, and standard deviation, z-score, linear, quadratic, and exponential models. Name, date, period, students, due date for my onliner. And we'll go right into page 1, which is a notebook entry. Page 1, quantitative data, number sets, such as heights, weights, test scores, tensile strength, and so forth. That's quantitative, meaning numbers. By contrast, categorical data consists of descriptive labels such as hair color, city of residence, socioeconomic status, and the like. Since the Level 2 mathematics subject test is unlikely to include questions about categorical data, the concepts described below pertain to quantitative data only, such as measures of center. Summarize a data set using a single typical value. 3 measures of center might be encountered on the Level 2 mathematics subject test, which are mean, median, and mode. The mean is the sum of all the data values divided by the number of values. The formula for the mean of a data set is mean equals the summation of xi over n, where the summation indicates the sum of the data values, xi, and n is the number of data values. So we have the sum of the data values divided by the number of data values entered into the sum. To determine the median, the data must first be ordered. If the number of values is odd, the median is a single middle value. If the number of values is even, the median is the mean of the 2 middle values. There is no formula for the median of a data set. The mode is the value that appears most often. There is no formula for the mode of a data set either. So let's get into an example here. A, the heights of the starting basketball team for South High School are 69, 72, 75, 78, and 78 inches. Find the mean, median, and mode of this data set. So here's our mean. We add up all our values, divide by 5. We have 5 entries here. And this will equal 74.4 inches. The median is 75. Here's our median. And the mode will be 78. We got 2 78-inch players. B, the mean of 24 test scores is 77.5. When the 25th class member takes the test, the mean goes down by 1.1 points. What was the 25th score? So the total of the 24 test scores up here, 24 times 77.5, is 1,860. And the total of the 25 test scores is 25 by 76.4. You'll see, what was the 25th score? It goes down by 1.1 points. So 1.1 is 77.5, so it'll be 1.4. So 25 by this number equals 1910. Therefore, the 25th score is 1910 minus 1860, which is a 50. What is the median of the frequency distribution? So what is the median of that frequency distribution? Shown in this following table right here. Here's our data values. Here's our frequency of each one of these data values here. There are 16 values altogether. 3, 7, 5, and 1 is 16. So the median is the mean of the 8th and 9th largest. So number 8 and number 9 of these values here would be our median. Both of these values would be a 25. It would be up here. These would be the 8th and 9th values here. 1, 5 would be 6, and 7 would be 13. So it'll be within the 25th data value there. So the median would be 20. A weighted average is another way of measuring the middle of a data set. The data consists of numbers, the averages themselves, for various categories that are to be combined to form an overall average. Higher weights are given to categories that are considered more important. To get the weighted overall average, the number in each category is then multiplied by the category's weight, and these products are summed across categories. So an example of this weighted averaging kind of a thing we can use here in some schools. AP courses, honor courses, and all college prep courses carry different weights in the computation of grade point averages. A given grade may carry a weight of 2 in an AP course, a weight of 1.5 in an honors course, and a weight of 1 in a college prep course. Suppose letter grades of A, B, C, D, and F are assigned values 4, 3, 2, 1, and 0. A student completes 6 courses with grades of B and a C in 2 AP courses, an A and C in 2 honors courses, and a 2 and 2 as in a college prep courses here. So what would the student's grade point average be? So with this situation here, the student's grade point average is calculated as the weighted average. So here we have 2 times 3 plus 2 plus 1.5 times 4 plus 2, and then 1 times 4 plus 4. So divided by 6. So we have 6 courses here, and we come up with a 4.5. Because our weights up here, again, we have a 2 in AP courses. We have a B and a C and 2 AP courses, that'd be here, and then an A and a C and 2 honors courses, that'd be down here, and 2 as in college prep courses. What would the student's grade point average be here? So we have 2 down here, college prep, so it'd just be 1 times 4 plus 4 here. So 2 A's, this is A's here, by the way. It's not 2 as in, it's 2 A's in college prep courses. So we have 1 times a 4 plus 4, and we divide this whole sum here by 6, and we get a 4.5. So with that, what do we do with that? The Level 2 mathematics subject test might ask questions about measures of spread. These questions ask about how spread out a set of data values is. The range is a measure of spread. It is the difference between the largest and the smallest data values, okay? So understanding spread, loosely speaking, the standard deviation is the average difference between individual data values and their mean. The formula for the standard deviation S of a data set is S equals, and radical 1 over n minus 1 summation xi minus x, meaning the mean here, xi minus the mean squared. The larger the standard deviation, the more spread out a data set is. Standard deviation is a unit-free measure of the distance between a specific data value and the mean. Thus, the standard deviation can be used to compare single data values from different data values or sets. A z-score, where z equals x minus the mean of x over s, is the number of standard deviations s that a data value x is from the mean. The greater the value of z, the absolute value of z, the less common the data value x is. In other words, fewer data values have a high z-score. So you have a high z-score, you're further away from the mean. So let's get into an example of that. Find the range of data values here, 85, 96, 72, 89, 66, and 78. So the largest value here will be a 96. Here's our largest value. And the smallest will be a 66. So the range will be a 30. And F, which data set has a smaller standard deviation, 5, 7, 9, or 4, 7, and 10? So the smaller deviation of these two data sets, both data sets have a mean of 7. Here's our mean here, 7 and 7. However, the first set is less spread. We have less spread here than the second. So the first has a smaller standard deviation. According to the formula, the standard deviation of the first data set is 2, while that of the second data set would be a 3. That'd be your standard deviation there. G, a chart that shows sports statistics for a particular school is shown below. We got some stats down here. Which is statistically a better score? 50.3 seconds in the backstroke, 50.3 seconds, or the 74 inches in the high jump. So statistically, meaning which is a better score relative to the present scores. So to respond to that, a time of 50.3 seconds in a backstroke would give us a z-value here of negative 1.75. This 1.5 standard deviations better or less than the backstroke mean. So it'd give us a negative 1.75 standard deviations. A height of 74 inches in a high jump would give us a z-score of 2.04. Standard deviations better, meaning more than the high jump mean. Therefore, the high jump performance is better. It's more advanced. It's a better score by 2.04 over 1.75. Measures of center and spread applied to a single variable. Regression is a technique for analyzing the relationship between two variables. This technique summarizes a relationship, such as mathematical equations, in which the two variables are denoted by x, the independent variable, and y, the dependent variable. The Level 2 math subject test may ask about any one of 3 models to capture the relationship between x and y. So we have a linear model, which would be a y equals a naught plus a1x. Then you have a quadratic model, which would equal a naught plus a1x plus a2x squared. And then an exponential model, y equals a naught e to the a1x. Okay, the first step when deciding which model should be used in a particular situation is to examine a scatter plot of the data. Enter the data into two lists, stat edit, clear the y equals screen, key second y equals, and select the plot. This takes you to the stat plot screen. Turn the plot on, select the scatter plot image, enter the list names, and key zoom stat plot. If the points in the scatter plot fall roughly in a straight line, enter StatCalc linear regression, either version. The calculator will return a linear equation. Linear models are appropriate when the dependent variable changes at a constant rate relative to the independent variable. If the points seem to change direction once, a quadratic model is probably appropriate. Enter StatCalc quadratic regression, and the calculator will return a quadratic equation in standard form. Quadratic models apply when the dependent variable varies with the square of the independent variable. Examples are A, the area of a figure varies with the square of the length of its boundary, and B, the intensity of light varies with the square of its distance from the light source. If the scatter plot is curved but does not change direction, an exponential model is probably the best choice. The command on the graphing calculator is StatCalc exponential regression. Exponential models apply when the rate of change in the dependent variable is proportional to the independent variables. Examples are population growth, the spread of disease, and nuclear decay. The figures below show scatter plots that have these shapes. Regression techniques use paired values, x, y, to estimate the parameter values A0, A1, and A2, depending on the model selected. Once this is done, the equation of that model can be used to predict y for a given value of x. So here is our linear, basically a linear scatter plot. This would be a quadratic scatter plot. Then this would be, they call this an exponential scatter plot here. The Level 2 Math Subject Test does not require students to know the mathematics of regression techniques. Students should know how to use their calculators to get parameter estimates for a particular model and how to use the equation as a prediction tool. H. The decennial population of Center City for the past 5 decades is shown in the table below. So every 10 years, here's our population here. Use exponential regression to estimate the 1965. So we need to estimate our 1965 population from our exponential regression model that we could construct from these data values. Transform the years to number of years after 1950 and enter these values into L4, list 4 on your TI. Then enter the populations in thousands. Here's your populations here in thousands. Set up the scatter plot by pressing second Y equals and selecting a plot. This will be plot 1. Turn the plot on. Select the scatter plot logo and enter the list names. Then press Stat Calc Exponential Regression list 1, list 2, blank Y, and then calculate. This will store the regression equation in Y1. The resulting command screen is right here. So this will be X list is L1, Y list is L2, frequency list will be store regression of equation Y1, and then calculate. So that should be on your, that'd be a screenshot of what you should have to set up your exponential regression. Then once you have that, then press enter to display the values. And then this is what you should have on your calculator as your values. Y equals A times B to the X power. This will be your A, B. This will be your regression line here, 0.99. And then this will be your R value here, 0.996. So it looks pretty good as this would be a good representation of your regression for those data set, for that data set. And once you do that, press zoom 9 to view the scatter plot and exponential curve. Press second calc value and enter 15 representing 1965. The cursor moves to the point on the regression curve where x equals 15, and this is where it should look here. X equals 15 on this curve here displays both x and y at the bottom of the screen as shown below. So x and y should be shown when you hit your enter 15, and you should get this population here, 79,300. So when x equals 15, y should equal 79,300. And that is your SAT Math Level 2 Prep lesson for statistics, lesson 21. Animated PowerPoint math video at AOL.com for questions or course materials. Thank you very much.